Hey guys, so like I said in my post yesterday, this is our last week we're going to spend on graphing stuff. So like linear relations, constant rates of change, coming up with pattern rules, scatter plots, all that kind of stuff. So our last week we're going to spend doing that. We're going to wrap up this unit. So what I wanted to do is create a 15-minute video going over all the main concepts that we've covered in this unit, kind of an example of each. I don't have enough time in this video to go over everything in depth, spend a lot of time on it. So what I'm going to say is, if I'm going through this video, which is going to be pretty quick, if there's anything that you're extra confused about or you want me to spend one-on-one some extra time with you and go over that, please let me know. Just because we're moving on to a new unit doesn't mean I don't have time to talk about these things, because it is important that you have an idea about what they are. Not that you have to know them perfectly, but grade 10 math builds off these concepts. So the more you can remember from grade 9, the better stance or spot you'll be in when you start grade 10. Not saying that they won't review all these things again, they will, but the more you can remember, the better, right? So 14 minutes left in this video I have. I'm going to try to go through everything, so bear with me. And any questions at the end of the video, please let me know. We can go over things one-on-one, all right? So this unit, we started off looking at tiles and trying to come up with the pattern rules that they follow. In this example, position 1 has 5 tiles, 2 has 10, 3 has 15. It goes up by 5 each time. So what we talked about is we wrote out the rules like this. Number of tiles equals position number times whatever it's going up by. Right? Number of tiles is number of tiles. Position number is what position it's at. And then times by how much it goes up. This example goes up by 5, so position number times 5. 1 up by 10 would be times 10, 1 up by 100 would be times 100, 1 up by 2 would be times 2. Whatever it goes up by, that's what you're multiplying by. We then moved on and replaced the word number of tiles with output. We replaced position number with input times 5, right? The reason we did that is because we're not always going to be comparing tiles and position number. We might compare distance and time, cost and distance, cost, the number of people going. Output and input just makes it easier for you to replace those words with anything else that you want, right? So output equals input times 5 would be the rule for this pattern. We then moved on and we added a constant, or 2 different colors. So just looking at the reds, there's 5, there's 10, there's 15. Goes up by 5 each time. So the rule just for the reds would be output equals input times 5. Goes up by 5 each time. 5, 10, 15. But there's also 3 yellows. 3 on the first one, 3 on the second, 3 on the third. Are they increasing with the reds? No, they're staying the same. It doesn't matter where they are, there's 3 of them. So that's our constant, and we always add our constant to the end. So the rule for this pattern would be output equals input times 5 plus 3. It's times 5 because it's still going up by 5 each time. It's just we don't start at 5, 10, 15. We start at 8, 13, 18. It goes up by 5. Just starts differently because of this plus 3, or the 3 yellow squares that are on each spot. So output equals input times 5. That's the pattern rule. Output equals input times 5 plus 3. That's that pattern rule. And then we introduced this little note here, which is on Google Classroom. It's important you don't forget about it. It's important that you understand and memorize this. Not memorize, but understand it. If not anything else, this will help you the most next year in grade 10. What we did was we just replaced what we have with more mathematical terms, right? So instead of output, we put y. Instead of input, we put x, right? Instead of times 5, we put times m, or whatever the multiplier is. And instead of plus 3, we're adding b. So let's do that example together real quick. So I'm looking at y equals m times x plus B. Y is our output, so Y stays the same. M is our multiplier, which is 5, right? So 5 times X still. X is our input, right? Input times our multiplier. Input times 5 is the same thing as 5X. And then B is our constant. That's 3. So this, Y equals 5X plus 3, and output equals input times 5 plus 3, mean the exact same thing. It's important for you to understand that. So if I was looking at this example right here, output equals input times 5, instead of output, I'd put Y. Instead of input, I'd put X. And then where do I put the 5? The 5 is my M. So I have to times that by the X. Y equals 5X. This and this are the exact same thing. Alright? Y equals mx plus b. Any questions about that? Please let me know. We can go over it together. We then learned how to connect graphs, tables, and descriptions. We kind of made it a little more real life oriented. So for example, a rental car costs $50 per day plus 20 cents for each kilometer you drive. What is the dependent and independent variable? Well, think about it. Does how much you're going to have to spend depend on how far you drive? Or does how far you drive depend on how much you're going to spend? The first one, right? How far you drive is independent of how much it's going to cost. How much it's going to cost depends on how far you're going to drive. So your dependent variable would be cost, and your independent would be x, or distance driven, sorry. What is the constant and the multiplier? Well, the constant is what's going to be the same no matter what. It's your starting point. In this example, $50. You're paying that no matter how far you drive. So constant is 50. What's the multiplier then? 20 cents. Because you have to multiply 20 cents by how many kilometers you drive. Multiplier. So constant, 50, multiplier, 20 cents. Make a table of values. Alright. So, if I drive 0 kilometers, 0 times 0.20, that's 0, plus 50, right? Because I have to drive 50, pay 50 no matter what. So I start at 50. After 100 kilometers of driving, 20 cents times 100 is $20. 50 plus 20 is 70. So I'd pay $70 after driving 100 kilometers. $90 after driving 200, 110, 130, 150. So if you follow the pattern, you have to spend $20 for every 100 kilometers you drive on top of your $50 to rent the car. Graphing that relationship, I did one for you right here. Let's take a look. It starts at 50, right? Because that's where we have to spend no matter what. We've driven 0 kilometers, but we still pay $50 to rent the car. Then every 100 kilometers you drive, it goes up $20. Up 20. Up 20. Up 20. Up 20. Up 20. That's what that graph would look like. Write the equation and model the following. Alright, so y equals mx plus b, right? That's what we're going to start. We're going to use that as our template. Y equals mx plus b. Y stays the same. M is our multiplier. What's our multiplier? 20 cents. We just said that, right? So M equals 20 cents. X stays the same. B is our constant. What's our constant? 50. $50. That would be the equation for that relationship, right? Is this partial or direct variation? It's partial because there's a constant. Wherever there's a constant, it's partial variation. Always, right? We talked about that too. Determine the rental fee for 45 kilometers. Show your work. Alright, so we just got to take the equation and put in 45 for our input. Y equals 0.2 times 45, because you drove 45 kilometers, plus 50, $59. So if you rent a car and drive 45 kilometers, you owe them $59 at the end of it. Simple enough. Any questions about that, let me know, because you're going to have to do that for me this week for your culminating task, alright? A very similar question. We then learned how to read a graph, we then learned how to read a graph, which we did right here. So we talked about a straight line like that goes straight up or straight down is constant because it's not curved, it's straight. Either constantly rising or constantly decreasing. Doesn't matter, either one. If it's horizontal across like that, there's no change at all. And if it's a curved line, either way, it's changing, but it's not changing at a constant rate. It's changing at different rates at each spot. That's what that is. All right. So straight line, constant. Horizontal line, no change. Curved lines, changing at different rates. It's important you understand that too. Then kind of the second last, one of the most complicated things we did was we learned how to find rate of change ourselves, right? So for this example that we just went over, our rate of change, it gave it to us, 20 cents a kilometer. We didn't have to find that. It gave it to us, we just had to plug it in. In this example, we have to actually find the rate of change ourselves. So let's do that together right here. We use this note to do it. Don't forget about this note either. This one's posted right next to this one on Google Classroom. They're both going to help you out with anything to do with this unit, so don't forget about these things. Rate of change, y2 minus y1 divided by x2 minus x1. That's what those things are. So in this example, y2, where's y end? It ends here, 15,000. Where does it start? 40,000. 40,000 subtract, so it ends here, 15,000. It starts at 40. This is y2, this is y1. So y2 minus y1. 15,000 subtract 40,000 is negative 25,000. x2 is 10, x1 is 0, right? 10 minus 0, 10. Negative 25,000 divided by 10 is negative 2,500. That's our rate of change, which is the same thing as our multiplier. Our initial value, our starting point, 40,000. That's where it starts. That's our constant. If we have to make that into an equation then, y equals, we always start with y equals. Say we do back to our formula, mx plus b. M is our constant, which is negative 2,500, same as the rate of change, right? Multiplier, rate of change, same thing. And then b is our constant, our starting point, 40,000. That would be the equation that represents this graph. Why is rate of change negative? Because it's going down. All right? This is pretty difficult. It's not easy math stuff. So if you have questions you want me to go over on how to find rate of change or make the pattern rule given a graph, let me know and we can do that, all right? Because you do a lot of this kind of stuff in grade 10, a lot of y equals mx plus b stuff in grade 10. And then the last thing we got to, which we started this week, was scatter plots. And this is actually one I asked you guys to do. We'll go over it together, all right? So scatter plots are like graphs, but it's just a little less organized than a line graph like we were doing at the start of the unit. So I graphed these points right here. This is what the graph is going to look like if you did it properly. That's the scatter plot for the height and the speed of a skateboarder. As you notice, as the height goes up, so does the speed, right? It's going up kind of on a line. Height is on the x-axis because height is the independent variable. Height is independent of speed, right? How high you go on the ramp is independent of how fast you go. How fast you go is dependent on how high you start on the ramp. So because of that, speed is dependent on the y-axis. Height is independent on the x-axis. This right here is the outlier because it doesn't match the rest of the data, right? These ones keep going up as we go over. This one doesn't. That's our outlier. So we did scatter plots, equations of a line, y equals mx plus b stuff, right? We did pattern rules, and we also did creating equations. Those are the things we did in this unit. Any questions, let me know. We can go over them one-on-one, all right?